Welcome everybody to today's topic about perimeter. Perimeter is pretty basic. I'm sure that you have seen or heard of it before in prior math classes. Let's just recap real quick what it means. Perimeter is the total distance around an object. So what we are looking to do is figure out the length of each individual side, and then we're going to add them together. Pretty basic. Now, this shape is drawn on a coordinate plane, so we can very easily count all of the units. I should notice that they have 4 along this side, 3, 2, 2, another 2, and 1 units. And now remember, we said that perimeter is the total distance around, so we're going to take each of these numbers and add them together. 4 and 3 is 7, 2 more is 9, 11, 13, 14. So our perimeter for this particular shape is 14 units, however long each particular unit happens to be. Okay, so maybe we're talking about feet, maybe we're talking about centimeters, doesn't really matter, but we're going to make sure that we label. That way we know exactly what we're talking about. Okay, the types of shapes that we're going to really be working with, because they're not going to all be this easy, we're going to, as you might even see at the bottom of the screen, we're going to have some coordinates going on. So we want to try to cut down our work as much as possible. So we're going to go over a couple of pretty basic shapes right now. We already know what a triangle is, right? Triangles very easily count the sides, okay? But a rhombus, rectangle, and square, they're all pretty special because we don't have to do all of the sides in order to find the perimeter. We can actually find maybe 1 or even 2 sides on each of these shapes and then just multiply. Well, let's look at each shape. A rhombus, okay, rhombus has 4 congruent sides. So I'm not going to have to go and look for the length of each individual side. That's a lot of work to do, when really I know that on the rhombus all 4 sides are congruent. So if I find just one side, I get the others for free. Basically just multiplying by 4. Okay, same idea with a square. We already know that squares have 4 congruent sides. So again, I just have to find one side, multiply by 4, and I will get the perimeter of a square. Rectangles are a little bit different. We have 2 sets of 2 congruent sides. 2 sets of 2 congruent sides. So if I find one of each of those sides that happen to be not congruent to each other, I will get the other 2 for free. So again, rhombus and squares, a lot easier to find the perimeter just by finding one of the sides and multiplying by 4. Rectangles will find one of each of the 2 sides, multiply by 2, and add them together. Okay, so you're going to see that happening in the examples. So let's take a look at what I'm talking about. This particular problem says find the perimeter of rectangle ABCD with A at -1, 5, that's up here, B at 2, 4, C at 0, -2, and D is at -3, -1. We're going to want to draw our picture or connect the dots. Alright, so here we have our rectangle. Now what I was saying before is that because we have 2 sets of congruent sides, if I find this length here and I find this length here, I can automatically get the length of this side and I automatically get the length of this side. Okay, it's going to cut down our work just a little bit. I'm going to show you 2 ways to do this. You should have already known how to do the distance formula from a few prior lessons. If you don't know the distance formula, I highly suggest going back and watching those videos, because I'm just going to start using it. And the other method I'm going to show you is the counting principle. Okay, so first of all, distance formula. Let's say that I'm trying to find from A to B. These are my A and B coordinates, so x1, y1, x2, y2. So y2 is 4 minus y1, which is 5, squared. X2 is b minus -1 squared Okay, distance formula. That's going to be -1 squared. This is going to be 3 squared. And here we have 1 plus 9, which is a distance of square root of 10. Okay, now that was for this length right here, AB, was the square root of 10. That means that we get CD as a square root of 10 for free. Okay, we're going to look at side AD. The other way that we can do this is the counting principle. I'm going to draw in what I call a ghost triangle. Maybe not with that pen though, doesn't seem to right. Okay, I'm going to draw in a ghost triangle. Now, what this is really going to do is it's going to help me find the distance between A and D horizontally and A and D vertically. What that really does is it finds this step for us right here. Okay, by drawing in this ghost triangle, we're actually doing a type of subtraction. We're just figuring out the lengths, which would go into here. So we're really skipping from here. We're skipping this step and we're going right to here. So we're still kind of using the distance formula in a way. We're just, instead of subtracting, we're just going to count. So we have a length of 2 and a height of 1, 2, 3, 4, 5, 6. So I can right away plug those numbers into the distance formula and just cut out a step. So I said we have 2 squared and 6 squared. That's going to give us 4 plus 36. Which is the square root, of 40. So we found this to be the square root of 40, which means we get BC for free as well. Now, the directions didn't actually say this. That was my mistake for not putting them there. We want to round, let's say, to the nearest tenth. I'll add that in there. Okay, so the nearest tenth, oops, I spelled that wrong. T-E-N-T-H. Okay, so if we were to find the square root of 10 to the nearest tenth, let's check that out right now. Square root of 10 is going to be 3.2. And square root of 40 is going to be around 6.3. So what we're going to do, perimeter, we're going to add up each of these side lengths. We know now what these values are. So we've got 2 of these 3.2s, and we've got 2 of these 6.3s. That's going to give me 6.4, and this is going to give me 12.6. And when I add, we're going to get, looks like 19 units. And that is rounded to the nearest tenth. We're going to do one more example on screen, and then I will give you the opportunity to try one on your own. So let's check out this problem right here. This next problem we're going to do together says find the perimeter of triangle QRS with Q at -2, 2, R at 1, 2, and S at 1, -1. I'm going to connect my dots. And here's our triangle. Now, this is a good thing because we actually found that QR, we can count those units. It's perfectly horizontal, and we find it to be a length of 3. We can also count RS because it is perfectly vertical. So again, we can count, this happens to have a length of 3. Now, you can use the distance formula to find QS. You can plug these in, your x1, y1s, x2, y2s, it's fine. We should also notice that we have a right triangle here. So we can actually just use Pythagorean Theorem, right? We have a squared, b squared equals c squared. So Pythagorean Theorem can save us a little bit of time. 9 plus 9 equals c squared. 18 equals c squared. We're going to take our root. And let's round to the nearest tenth. I apologize for not putting that on the directions. Square root of 18 to the nearest tenth is 4.2. So we found QS to be 4.2. So remember, perimeter is the total distance around, so to finish this problem off, we want to add together 3 plus 3 is 6, plus 4.2 gives us 10.2 units. Okay, so I have one more problem for you. Remember, I told you a trick about different types of shapes, so look at the type of shape you have. You can use the shortcut. Round to the nearest tenth for this problem. Take a minute to try it on your own, pause the video, and resume it when you're ready to check your solution. Alright, let's see how you did. We want to plot this first, so 2, 0 for L, -1 for M, -2, 2 for N, and 1, 3 for O. Well, squares, very nice about them is that we can just find one side multiplied by 4 and we'll get the perimeter. Nice. So let's just use the counting principle. I find it to be a lot easier when you have a coordinate plane in front of you like this, and there's nothing wrong with doing that because, again, we're still using technically the distance formula. We're just taking a shortcut. We're doing the subtraction by visually counting. So we have 1 squared plus 3 squared. That's going to give you a distance of 1 plus 9, which is going to give you square root of 10. Hey, didn't we have the square root of 10 a minute ago? Let's see, we said square root of 10 was 3.2. So we find this length right here, NO, as 3.2. Well, remember we said perimeter was going to be 4 times 3.2. So 3.2 times 4 gives us 12.8 units. How'd you do on that one? I bet you got it correct. Pretty easy problems to work with. Any questions about perimeter, please either leave on the website or bring them into class. I would love to be able to help you out with it. Until next time.